Good day. So in this tutorial, I will be starting a new series of tutorial on MIPS. MIPS stands for microprocessor without interlocked pipeline stages. So when you go to my website, you will see a lot of write-ups and explanation on MIPS which I've written. I'll give a link in the description below. So I'll give a link in the description on where you'll find the lesson where I gave the explanation on MIPS, microprocessor without interlocked pipeline stages. So the description is brief. You can go more on Wikipedia on any other sites to get the full explanation of what it involves. But in this tutorial, I'll just be giving a practical explanation using Verilog. There is a long code. You likewise see it on MIPS. Then I'll be explaining it using Logisim, what MIPS is. So this class is more of the practical aspect. Hopefully you understand the mere definition. So what you are seeing here is a typical example. This is a 16-bit MIPS processor, microprocessor without interlocked pipeline stages. So this is a typical 16-bit MIPS. So we'll briefly dive into it and see what it consists of. So this is the internally what it looks like. So let me zoom it in more to the center. So what is very common and familiar with MIPS is that it processes information in pipeline. I also gave explanation on what pipeline means. It means taking taking a processing from one stage to another rather than the random, probably the normal von Neumann architecture or Harvard architecture. But here, processes are done stage by stage. So I'll just show you what it means to be a pipeline. So this is how this stage actually moves, like to here and back here. So this is the instruction fetch stage to instruction decode stage to the instruction execute stage to the memory stage. This is more like the storing stage. This is the write back stage. This is the register. This is where it's stored finally, the register, and from here it can be accessed also. Now this is the Harvard detection. This is hazard detection, sorry. So to detect for error in the process. So this is what makes it a pipeline processing. It moves from stage to stage like a pipeline, unlike the usual CPU. Like if you go to my previous tutorial on 6502, you can find out that it doesn't go in a row like this. It's more like each connecting to the common bus, to the central CPU bus. So the pipeline structuring has a lot of advantages. All these are the theoretical aspects which I won't be covering in this tutorial. I gave a little write-up on my website about it also. I'll just show you practically how this is. So this circuit is a Logisim circuit actually, but the Verilog code which I used to translate it to Logisim is also on my website projectfpga.com/mips. Please subscribe to my channel and like the video. Thank you. So I'll just give a round view of what they do, then I will now talk about each of these subgroups individually. So this is the instruction fetch. You know, the thing about CPU always has to do with fetch, decode, execute, store. So let's start from this is the first one, the instruction fetch. So what happens here is here is where you get the program counter. It's more like a program counter that is counting one, two, and looping through different sets of instructions from one instruction to the another, from one instruction to another. So it takes as an input clock and reset. If you've been following my tutorials, every sequential circuit will have a clock and a reset. So these are the major inputs here. The instruction fetch enable. Once it's enabled, you can select the instruction, and then this is the branch offset and the branch taking bit. This is used to jump the program counter. Like if you are familiar with CPU, you know that if your program counter is counting from bit to bit and then you get a jump instruction, you need to jump to a certain program in the memory. So then that is how you get this instruction. So from here it goes to the instruction decode. The decoder is a very so at this stage is where this 16-bit instruction is decoded, is being separated and transcribed into whatever information it has. So you can see that it has a lot of output. This is like more like the CPU if you are going to compare it to the normal processor with like the 6502. So this decode stage does a lot of the function here. So it has a lot of outputs that went to different parts of here, but still note the pipeline. So you can see that from this output it went here, from this output it goes into here, from here it goes into here, from this output it goes into here, from here it goes into here. So this is just for detecting error detection circuit. So when it gets to the execute stage, this stage is where you get the LU, where the LU does the multiplication or division or addition or subtraction. Then after there, it goes to the memory stage. At this memory stage, you are accessing the memory register. There are three registers actually. You have your memory register here, you have your instruction register where the instruction are being gotten, and then the register, the one that is being accessed by the decoder. So here is where it's stored first. From here it goes to the write back stage. The write back stage, from the name it writes it to this main register here, and from this main register here it goes back all over here, back again. But this decoder, the instruction fetch, the program counter is just counting one, looping and selecting which instruction to be decoded here. So this movement from one stage to another, moving from one stage to another to here is what is called the pipeline. So that's where the MIPS gets the name microprocessor without interrupt pipeline stages. So that is all about this MIPS. The Verilog code, I have it in the description. I'll give a link. When you go to my site, you can see it. Is a reference. I got it from OpenCore. When you go use OpenCore, you see a lot of projects there. So I actually wanted to explain this particular one because it's more simple and easier to understand the working of MIPS. So the next tutorial I'll be going deep to explain how each of these subcircuits work. Mind you that the Verilog code is there also on my site. There are a lot of them. So each of the code I actually explain them one after the other. So each of the Verilog scripts actually contains each of the stage. So this is like if stage.v, id stage top.v, ex stage.v, and so on and so forth. So all these you'll see them on my website. I'll give a link in the description. Please like and subscribe. Thank you.